As I've mentioned before, the most important part of this module is to be able to solve word problems with fractions. In this video, I am going to discuss several different examples of problems you will need to be able to solve. In addition to discussing fractional word problems in this video, I also have different worksheets you can look at, along with the worked out answers, to aid in your understanding. Rather than just watching me do the problems, I encourage you, after seeing each problem, to turn off the video and attempt it yourself first. Afterwards, you can turn the video back on and see how I approach the problem. It is important to remember, however, that there are all sorts of ways to do a problem, and you and I may do them different ways. As long as we both come up with the correct answer, it does not matter how it is done. So here's the first example. Joe and Mary own all of their company's stock. They decide to give their son 1/6 of the stock and their daughter-in-law 1/8 of the stock. What fractional part of the company's stock will Joe and Mary still own? In order to do this problem, the first thing I would probably do is to figure out what fractional part of the stock they are going to be giving away in all. So, according to this, they are going to be giving away 1/6 of it to their son and 1/8 of it to their daughter-in-law. If I go through and find out the total amount by adding these together, 1/6 is the same as 4/24, 1/8 is the same as 3/24, so altogether they are giving away 7/24 of the stock. The important part to remember here is that they owned all of the company's stock. And when they owned all of the company's stock, they own 100% of the company's stock. Well, 100% is the same as 1. So I want to subtract 7/24. Well, I don't have a fraction here, so I'm going to think about that 1 as 24/24. And 24/24 minus 7/24 means that they are still going to own 17/24 of the company's stock, which is the answer to the problem. This idea of the entire amount being equal to 1 is going to be very important in many of the problems that we do here. Here's example problem number 2. At a meeting at a local company, 2/3 of the people drank coffee, 1/8 drank tea, 1/12 drank pop, and the remaining 12 people drank water. How many people were at the meeting? How many drank each type of beverage? In this particular problem, you are given two different bits of information. You are told the fractional amount of people that drank the three different beverages, the first three, and then the actual number of people that drank just water. So we have to use that information two different ways. First of all, I could figure out the fractional amount of people that drank the three different beverages that I know. 2/3, 1/8, and 1/12. So I'm going to add those fractions together so that I can figure out the fractional amount of people in the company that drank those three different beverages. So, as I go through and do that, and once again you might be doing this on a calculator, but I'm doing this quickly by hand here, I find that 21/24 of the people at the meeting drank either the coffee, the tea, or the pop. I'm going to put that into lowest terms because it makes things a little bit easier. So 7/8 of the people drank one of those three beverages. If that's true, that must mean that 1/8 of the people are left, because 7/8 plus the 1/8 would give me the 8/8, which is equal to that 1 that I talked about in the previous problem. Knowing that there are 1/8 of the people left, that helps me solve the rest of the problem, because I know that 1/8 of the people that are left is the same as this remaining 12 people. So 1/8 of the people in the company at this meeting is equal to 12 people. Well, if 1/8 is equal to 12 people, I just want to draw a little picture here just to kind of represent this. If I took this circle and divided it up into 8 equal pieces, every eighth of this is equal to 12 people. So I could put 12 in here, but this would also then tell me how many total people are in the company. I need to multiply 12 times 8 to get the total number of people in the company. So there must be 96 people in the company at this particular meeting, which gives me the answer to the very first question, how many people were at the meeting? 96 people. Now I just want to know how many people drank each type of beverage. And I know that 2/3 of the 96 people drank coffee. The word of is a very important word in many word problems. The word of generally means to multiply. So I'm going to take 2/3 times 96, and that would give me an answer of 64 people drank coffee. I'll do the same thing with the people that drank tea and pop. It says 1/8 of the people drank tea, so 1/8 times 96 gives me 12. It says 1/12 of the people drank pop, so I'm going to go 1/12 times 96, and that gives me 8. So I have the answers to the problems that I need also as far as how many people drank each of the other types of beverages. Practice problem number 3 says, a metal rectangular plate is 4 inches wide by 6 inches in length. Holly drills 3 holes in it, all in a row. The middle hole has a radius of 3/4 of an inch. Both of the outer holes have diameters of 5/8 of an inch. The distance between each hole is 1 inch. What is the distance between the centers of the outer holes? There's no way that I would go through and do a problem like this without drawing a picture of it first. So I'm going to sketch a picture of what this might look like. She has a metal rectangular plate that's 4 by 6. I'm not going to draw the plate, but I am going to draw the 3 different holes. It says the middle hole has a radius of 3/4 of an inch. So I'm going to draw a big circle here, and that would be the middle hole, and then both of the outer holes have diameters of 5/8 of an inch. So here are the outer holes right here. The question says, what is the distance between the centers of these outer 2 holes? So I want to know, what is the distance from there to there? That's the question that's being asked. And it does give me some other information. It says that the middle hole has a radius of 3/4 of an inch. So the question is, what do we mean by radius? By radius, we mean the distance from the center to an outside edge. So that means that that is 3/4 of an inch, and that is 3/4 of an inch, because that is what is meant by the radius. It also says that both of the outer holes have diameters of 5/8 of an inch. So a diameter is the distance from one edge of the circle to the other edge through the center. So I know that the entire diameter here is 5/8 of an inch. Well, if I want to find the distance from the center here to the center there, I'm going to need to know what is this distance right here. It does tell me that the distance between each hole is 1 inch, so I know that's 1 inch. I'm going to also need to know this distance from here to here, which I do know. It's 3/4 plus another 3/4. I know that this is the 1 inch, and I need to figure out what this distance is. So I'm going to add up all those amounts. In this problem now, I really have been given all the distances except for this one distance here, which is the radius from the center to the outside edge of the smaller 2 holes. So I want to find out what is half of that. So I'm going to take 1/2 of 5/8. Of, once again, means to multiply, so I could go 1/2 times 5/8, which is equal to 5/16. So I know that this radius right here is 5/16 of an inch. So now all I need to do is add up all the numbers that I have. I have 5/16 for this radius. Then I have 1 inch. Then I have 3/4 of an inch. Then I have another 3/4 of an inch. Then I have 1 inch. And then this radius is also going to be 5/16 of an inch. So I'm going to add up all these numbers. 5/16, 1 inch, 3/4 of an inch, 3/4 of an inch, another 1 inch, and 5/16 of an inch. And this is sometimes where I might want to go to my calculator because I'm adding up so many fractional numbers. If you do that, you will get 4 1/8 inches would be the distance between the centers of those outer two holes. Practice problem number 4 says, a small pool needs to be filled to 5/6 of its capacity. The pool is now 1/3 full and has 30 gallons in it. How many gallons will be in it when it is 5/6 of the way full? Once again, I'm going to draw a picture of this, and I'm actually going to be doing this problem 2 different ways because I want you to see 2 different ways of doing it. So here's this pool, and this pool, this picture, you are looking straight on at the pool, and it says it needs to be filled to 5/6 of its capacity. But right now the pool is 1/3 of the way full, so this is the 1/3 mark right here, and it is filled up with 30 gallons. If this is the 1/3 mark and this is the 2/3 mark, that would be another 30 gallons. All the way up to the top, its capacity would be all the way filled up, would be another 30 gallons. So all the way filled to the top would be a total of 90 gallons. It says it's going to be 5/6 of the way full. So I want to know what is 5/6 of 90. So I am just going to multiply once again 5/6 times 90. And if I do that on a calculator, 5/6 times 90 gives me 75 gallons for an answer. Another way of doing this particular problem, I'm going to draw once again my picture. Maybe I'll draw it a little bit better this time than I did last time. And this is 1/3 of the way full, and it is 30 gallons. You could look at this and say, if it's 30 gallons, 1/3 of the way full, well, what is half of that? Well, half of 1/3 is 1/6. So 1/6 of the way would be half of that 30 gallons, which is 15 gallons. So 15 gallons is 1/6 of the way filled. Well, I want a total of 5/6. So how many sets of 1/6 do I need to get to 5/6? I would need 5. So another way you could do it is now 15 gallons times 5 sets of those also gives me an answer of 75 gallons. And you can go through and do the problem either of these 2 ways. There are other ways to do it as well. But once again, notice that drawing a picture possibly helped. Practice problem number 5. Bill eats 5/8 of a cake. Sally eats half of what is left. What fractional amount of the original cake did Sally eat? Once again, I'm going to draw a picture to illustrate this problem. So here's this cake, and I'm going to divide it up into 8 different pieces. It says Bill ate 5/8 of the cake, which means that Bill would have eaten this amount of the cake. It says Sally eats half of what is left. Well, what is left is this section right here, which is 3/8 of the cake. So if Sally eats half of that, the question is, 1/2 of 3/8 of the cake is what? Of once again means multiply. So I'm going to multiply 1/2 times 3/8, and I get 3/16 of the cake was eaten by Sally. In this video, I have tried to give you several different examples of fractional word problems. However, there is no substitute for doing a lot of different practice problems on your own, so you can become better at it. Years ago, I once used a math book for this class, which is now out of print, titled, "Math is not a spectator sport," which is very true. Although practice may not make things perfect, it certainly helps. There is a 5-question quick check that you can do after this video to check your understanding. If you do well on it, you may be ready to take the assessment on this module. However, please remember that there are also additional practice problem worksheets in the module that you can also do for more practice before taking the assessment. Please feel free to contact me as well if I can help clarify anything in this module. Thank you.